Hi there and welcome to this example video on electrolytic cells. Let's read the question. This comes from a past question paper. The apparatus below is used to demonstrate the electrolysis of a concentrated sodium chloride solution. Both electrodes are made of carbon. Okay, the few drops of universal indicator are added to the electrolyte. So here's our electrolyte. Universal indicator is added to this, which gives it a color. The equation for the net cell reaction is the following. So this is what they tell us is happening as a result of this electric current being passed through the electrolyte solution. Okay, so we'll remember that in an electrolytic cell, that's what they tell us, it's the electrolysis of concentrated sodium chloride solution. What that means is that electrolysis is in an electrolytic cell. A current is passed through an electrolyte solution that causes a non-spontaneous reaction. That means a reaction that would not occur by itself to occur. Initially, the solution has a green color, okay, because of the indicator. The universal indicator becomes red in an acidic solution. So initially it's green. In an acidic solution, it would become red, and it will become purple in an alkaline solution. So acidic means that there are an excess of H plus ions, and alkaline means there's an excess of OH ions. Okay, let's see. Define the term electrolyte. Define the term electrolyte. Okay, so electrolyte is literally a compound that ionizes, that means breaks up in ions in a solution, in an aqueous solution maybe. Okay, that's the term electrolyte. When the power source is switched on, the color of the electrolyte around electrode Y, so here's my electrode Y. Okay, the color here changes from green. Remember they said that initially the solution had a green color, changes from green to purple. So now it's changed to purple, and they ask us to write down the half reaction that takes place at electrode Y. Okay, so at electrode Y, what is happening? Well, let's just think about it. I haven't done this question before, but at electrode Y, it means that we now have OH, because it says alkaline solution. Now, alkaline solution means there must be now OH ions at this point. Now, what has happened is that we have sodium plus ions, chlorine negative ions, H plus ions, O2 negative ions, and then we have chlorine with a 0 oxidation state, hydrogen with a 0 oxidation state. We still have sodium with a +1 oxidation, and oxygen and hydrogen now become OH, but they still have 2 negative and 1 plus. Okay, but you notice that hydrogen itself, okay, used to be part of water, H2O, and then it became hydrogen gas. So we used to have H plus, then we lost, or we gained 2 electrons, okay, and that produced for us hydrogen gas. And then also what we had is the chlorine, and here we needed 2 of these. Chlorine itself, who was 1 negative, must have donated 2 electrons to produce 2 chlorine. So the two chlorine ions would donate 2 electrons to produce chlorine gas. Now the question is, both of these electrodes will produce gas. So both of these electrons are producing gas, and the question is, which gas is producing at which electrode? All they tell us is that at electrode Y we see a change in color. Now what that tells us, if there's a change in color to purple, is that here we have hydrogen ions are gathered around here. Now hydrogen has a negative charge. Now that means the negative charge of hydrogen would be attracted to a positively charged electron. Does that make sense? So this is a positively charged electron, which means this is a negatively charged electron. If this is a negatively charged electron, electrons are being fed towards this electrode. So if electrons are coming towards this electrode, then this means that this electrode is the one that donates electrons to hydrogen. So this is hydrogen gas at this point, and this one is then the at this point we have the chlorine gas escaping at this one, because chlorine is the one that is donating its electrons, which it donates into this, which donates it back into this system up here. And now when chlorine has donated its electrons, it used to be part of sodium plus, and sodium now gets reacts with the hydrogen. It's the hydroxide ion left, because one of the hydrogens in the H2O solution, one of the hydrogens has now received an electron. Another hydrogen received an electron, leaving the hydroxide ion by itself. But nevertheless, you didn't need to know all of that. All you needed to know is which side would be the positive and which side would be the negative. That once you know that, then you know which one is getting the electrons, which one is donating it back into the outside circuit, and then you can determine, well, what is happening at what side. So let's see what they say. Write down the half reaction that takes place at electrode Y. So at electrode Y, this is the half reaction that takes place. Chlorine negative is losing an electron. So it's losing an electron to produce chlorine gas. Now chlorine is a diatomic molecule, so Cl2, so that means we needed 2 chlorine ions to lose 2 electrons to produce 1 diatomic chlorine molecule. What is the name or formula of the gas released at electrode X? That would be hydrogen, or H2 gas. Refer to the table of standard reduction potentials to explain why hydrogen gas and not sodium is formed at the cathode of this cell. Okay, that's actually a very good question, because sodium is also positive. So why isn't it that sodium, or there's hydrogen ions and there is sodium ions in here, cations? Why is it that at the cathode, and remember the cathode is the one that receives electrons, so the cathode is the one that receives electrons. Why is it that when the cathode receives electrons from the outside and donates electrons into the solution, why is it that hydrogen gets them and not sodium? And if sodium was formed, we would have small little solid particles starting to accumulate at the bottom, or the sodium would would plate the electrode itself. It depends. Okay, but anyways, why is it that hydrogen gets the electrons and not sodium? So we look at our standard reduction potential table. And let's just again explain to ourselves, what does the standard reduction potential table mean? Now remember what it means. What reduction means is, it means it's my ability to gain electrons. This is a table that measures an element's ability to gain electrons. Reduction means I'm gaining electrons. So the more positive this result is, all of them were compared to hydrogen. Hydrogen's ability to gain electrons from itself is 0. Obviously I can't gain electrons from myself. anything that is less than 0 means that hydrogen would gain electrons from these elements. So in all of these cases, if hydrogen was reacting with all of these in a galvanic cell, it would be able to get the electrons from these. So hydrogen will take electrons from lithium with a lot of force, okay, that it would be very strong at getting it. However, on the other side, once the values are positive, it means that these, in the tug of war, these elements or these compounds or these ions will gain the electrons. So for example, the fluorine gas is the most electronegative. He has the biggest desire for electrons, and so fluorine will gain the electrons with a very strong force pulling on hydrogen. So the question is now, why does hydrogen in this electrolytic cell, why does hydrogen get the electrons and not sodium? So let's see. Here hydrogen, if it was in a tug of war by itself, it would be 0. So we're comparing it with itself. But here is sodium. For sodium to get 1 electron, its reduction potential in a tug of war with hydrogen, it will lose because its value is negative. It will rather donate electrons to hydrogen than it would be able to draw them from hydrogen because it's a negative value. I can't think of any easier way to explain it. This is a lovely table, and so that is what we would explain here, that according to the table, hydrogen has a greater reduction potential than. So reduction potential talks about its ability. Potential is ability. Its potential to be reduced. Its reduction potential, a greater reduction potential than sodium. So it would get the electrons, it would get the electrons rather than sodium would. So not very difficult. I hope you enjoyed learning or going through this example with me. Thank you for watching. We'll see you in the next video.